Dear friends, welcome back to Data Analytics Talks. So, this video, I would like to share some more experience on NDMO RMD specification. Let's see what is RMD 2 domain. Under that, RMD 2.2 specification and 2.3 specification. So, in the last video, we mentioned like what is NDMO. NDMO is a National Data Management Office, a regulator for the data available in the country of KSA, and they are providing data management and personal data protection standards. And RMD 2.2 and RMD 2.3 are two of the P1 category specification. Let's see what is RMD 2. RMD is belongs to the domain reference and master data management. The control is architecture. Under this architecture, the entity shall develop and document its requirement for effectively managing its reference and master data, evaluate and select a reference and master data hub architecture design, develop a conceptual and an information architecture for its target reference and master data environment, and document the technical requirement for its reference and master data hub platform. That's the overall control specification. Under RMD 2.2 and the RMD hub design, in which the entity shall evaluate and select the reference master data hub architecture design to effectively manage its reference and master data objects. The entity shall determine, based on its RMD requirements, which of the following data hub architecture implementation pattern is most suitable for managing its master data objects. So it's basically identifying, evaluating the right master data hub architecture for suitable for the entity. And coming to 2.3 specification, it is RMD conceptual architecture. It is a high level architecture in which the entity shall develop and document a conceptual architecture for its target reference and master data environment as per the entity's selected hub architecture design. So it's a continuation to our point 2.2 where we are selecting the RMD data hub design. Based on that, build a conceptual architecture. The conceptual architecture shall indicate foundational building blocks, components, and high level capabilities associated with the components. The conceptual RMD architecture shall consist at minimum the following: the architecture description, that is the description of the overall architecture concept and defined, then the component definition and description, building blocks like data hub, data sources, consuming application, etc. of the RMD conceptual architecture with a description of their purpose. And the conceptual architecture diagram, how the high level view of how components work together to address the entity's RMD requirements. So these are the two specification that we can see today. So first of all, RMD 2.2, in which we are going to evaluate the RMD data hub designs. So basically, there are four types of RMD design hub. The first is the registry hub. So what do you mean by registry? The registry is, maybe you can think about an index, right? And in the registry hub stores only the key identifier as an index. So basically, if you have the physical existence of the data in databases, um, and you have a index, we take the index and you maintain that index, okay, and which will be a pointer to the physical data, and that's what is called registry hub. Again, I will repeat: the registry stores only the key identifiers as an index, while the master data remains and it's managed in its original source system. So we have uh, different source systems. As we were mentioning about the insurance domain, we have the core insurance system, and we have the CRM system, which is a relational management system. Then we have finance system, and the finance system, and we have a claim processing system, and we have even multiple marketing sites or portals, right? So we have physically the data store in their databases, but when you want to build a master data hub, then this is one of the architecture where we just point to those physical databases using an index, and but we are not bringing the data into the any central repository or not. So what is the relevance for that? When are we going to use a registry hub? Basically, when systems are distributed and there is no need to bring them into a real-time physical system, then go for this registry hub design. Okay, so if you want to see it closer look, you can see we have the source systems 1, 2, 3, and we have an index system, that's MDM, and we have the downstream applications. Okay, so in this scenario, we are not bringing data from the sources to the index, that is MDM. We are only just maintaining an index. So when someone is accessing the master data, this index will be pointed to the actual data tables, and this index being served for the downstream applications. Okay, so that is the registry hub architecture. Then the second type is a repository hub architecture. What's a repository means? A repository hub copies, matches, and consolidates master data from source system into a central hub. Okay, that is a repository. You are going to bring data from all the source systems into a centralized system. Okay, but the catch here it is the master data is synchronized one way from the sources, with creation and updates managed at the source only. Okay, so we will create the master data in the source system, but we are bringing that master data into a centralized system. We are not pushing back. So we are not syncing back to the source system, and all this insertion updation of the master happens in the source system. And when it is this ideal for centralized storage used in analytical and reporting. For example, when you have multiple source systems, and you want to create an analytical database and reports, dashboards, AI, then you can bring all the data from the sources into a centralized MDM, and that MDM will serve as a source for the master data. So if you look at closer to the registry hub, a repository hub, you can see these are the source systems, and you bring the data to MDM repository. Okay, and basically that the data itself is being shared for the downstream application. So here the steward is going to manage, okay, control the MDM, but the updates happens at this level, insertion happens at the source level. Okay, so that's basically the consolidated hub design. So basically for reporting purpose, a repository recommended. Next step is a coexistence hub, because it is like the consolidation hub, but adds a feedback loop to source applications for golden data. Then it is user friendly, but brings notable technical and organizational challenges. Downstream streams rely on trusted golden records while source systems stay the same. Okay, source systems are not getting updated, but they are having a feedback loop back to the source applications. Okay, so if you look closer to the design, you can say, so we have, these are the source systems, then we have the MDM, then there is a stewardship, then we are having a downstream application, but you can see there is a feedback. It's like a hybrid scenario. It's a hybrid scenario. So an update happens here again, um, but the source, again this updates are happening at the source, and it is coming to MDM again. It is updated in the source also, right? That is the coexistence. Then coming back to The last hub scenario, we have the centralized hub. What's centralized hub? The centralized hub master data records are moved to centralized data hub. It serves as the sole source for creating, modifying, and providing the master data to all consumer application. This approach is also called a transactional system. So it's very clear from here. So the master data is updated but the central location. Okay, and it is other the input sources are going to consume that, as well as the output sources are also going to consume from the MDM. So that's a centralized style. So we have four types of hub. One is a registry, where we are just using index, but the actual data lays in the source itself. And we have the repository, where we are collecting data from sources and keeping a repository. Again, the downstream applications are using from there. Then we have coexistence hub, where you bring data from the source to the hub, and again there is a loop back to the source systems. And finally, we have a centralized hub. Centralized hub, the master data is safe at the sender, and insertion, updation, everything happens at the send, and the input sources as well as the dashboards or outputs are expected to use the MDM from the centralized hub. So we have seen four type of hub design: registry, repository, coexistence, and centralized. So what we did next is we explained the pros and cons of each hub design, and we also explained some of the business scenarios, business drivers that help adopt any of this hub design. So let's look into the pros and cons and some of the business drivers, and that will really help us to take this to the next level, because our goal is to uh, come up with the best suitable hub architecture. Then take registry. The pros are like it is very easy to deploy. The source data source is not changing in this case, and still keep till with the source itself. We are not building a new repository for a registry hub. That itself is a pros, right? Because it will serve the purpose without much effort. And the con is, for example, tomorrow you want to transition these to another mature style, is going to be difficult because of the significant architectural differences. And secondly, this is not going to improve the integrity of the master data into the operational systems. So we have pros and cons, and now again, in spite of that, what will be the business drivers? Why it is as an approach? Now, for example, when business wants to minimum system disruption with a non-invasive approach, then we should go for this registry. Sometimes they need a real-time central reference to keep the metadata up to date. In that scenario, we can also recommend the registry hub. Okay. Then another important hub design is a repository. Uh, you know, it has pros and cons. The pros is like the location of the master data is a new repository, a reference and master data repository, which is no more the source. Then it provides the most information needed for reporting of master data. Okay, this is a separate repository, and it is providing you most information needed for reporting purposes and analytical purposes. And coming to the cons, it requires of additional effort to consolidate necessary attributes. That is a big thing, and also does not enhance the master data integrity in the source system. See, the repository is basically we are taking the entities from the sources and to build a repository, and you are pumping into the RMD repository, and there is no change happening in the source. So that itself is a is a con. Like it is not going to enhance your master data in the source system. Correct. So that is a cons. But still, there are some business drivers. It supports analytical reporting needs because you have golden record in the repository hub, and it can be distributed for your analytical purpose or AI use cases and so on. Then um, when the business is not looking for a synchronization back to the source system, because there are multiple source system. Again, the transaction systems, they have to make amendments to adopt to the new master data if you are pumping back to the source system. But in businesses not looking for such scenario, you can go for repository. And thirdly, okay, um, when the business requires a complete record identification, that scenario also repository is a good option. Um, then coming to the third hub design, the third one is a coexistence. As the name suggests, it combines the strength of registry and the consolidated hub models, supports the bidirectional synchronization of master data with the source systems. That is the cons. That is the pros. And coming to cons, like us, it comes with additional data integration efforts between the RMD hub to synchronize back to the source application as compared to the consolidated pattern. Consolidation, we are not synchronizing back to source system, correct? But in the coexistence, we need to do that. That brings a lot of additional effort for that. Then the business drivers, what are the business drivers for coexistence? Basically, it requires a when the business requires sync across database and central references, then we should go for coexistence. Then when the business wants to have a phased transition to transactional architecture, because we have transactional MDM and we have analytical MDM. Transactional MDM is something that is supporting the transactions of that organization. So when the organization looking for a transactional MDM, we should go for coexistence. Then the final one is a centralized one. Centralized, as the name suggests, it is everything is consolidated into a central location. Um, what is the pros? It delivers timely, unified views of the master data to supporting applications from one location. So, as the name suggests, all the applications, both transactional, analytical, will start using this centralized hub. Okay, so that itself is a beauty of centralized, but there is a cons. What is a con? It's a highly evasive, requiring direct consumption of master data by operation system. Okay, and complex to implement, suited for organization with mature RMD and governance practices. So if the organization do not have a mature RMD and then governance practices, no, it's not practical to go for centralized. And there are some business drivers that are like a scalable master database for transactions, support long-term architecture goals, centralized master data controls. These are some business drivers going for centralized. So we have registry, repository, coexistence, and centralized. And we have discussed these pros and cons with business, with IT, and we come up with option is repository hub model. Okay, the repository hub model, we are bringing to the master data into a central repository. We are not doing a synchronization back to the source system, and this is good for analytical databases, analytical reports, anything for the downstream application. Okay, so next we will see how we have built the architecture, conceptual architecture for this repository hub.
So next is RMD 2.3, where we are going to do a conceptual architecture. So in the conceptual architecture, we have to consider the building blocks. We have the inputs, we have ingestion, we have a repository, we have stewardship, which is a part of governance, and we have the consumption layer. So let's see how we are going to build the architecture, and let's consider the important layers. The first is we have to have the input source. We have various sources, and it could be of different technology, maybe Microsoft technology, Oracle technology, or it could be SAP. No, it is irrespective of the technology. We have a lot of sources could be there, and you need to bring that into our repository. For that, you will have to have an ingestion layer. Then we have the repository. Then once you have a repository, we have to have a governance layer, which is taking care of your RMD, and the RMD will be consumed by the your analytical applications or downstream applications. So we let's consider 5 layers in our conceptual architecture. The first thing is the data source layer. As I mentioned, if you are working in an insurance, you will have multiple source systems, maybe a core system, financial systems, then claim processing system, and CRM systems, and they may have different technologies as well. So as a repository hub, we need to bring the data into our repository. Okay, for that you may use some ingestion layer. That's the second layer, ingestion layer. And this ingestion, of course, can be implemented using uh, tools. You can find industry leading softwares for implementing this data ingestion. You can even use your Python code for bringing data, or you can use Informatica kind of enterprise MDM tools, right? It is available mostly on cloud as well as on on-prem. So use any of the MDM tools for integrating your source system to the layer. Then, once you have the data brought into your landing zone, then you need to execute MDM process activities, especially kind of think the data quality check. Then you have the relationship management. Then you have the golden record management, match, merge, relate. Then you need to have the data modeling, as the source model may not be fitting to your RMD model. You have to do a data master data modeling. Then finally everything is set. You have to store your golden record in your master data repository. All this happens in your silver layer. Okay, and then we can go for a consumption layer. The consumption layer basically is going to consume your RMD either directly to your analytical applications or your data warehouse, and from the data warehouse also the consumption can happen. Okay, of course there is another layer which is part of the governance layer. Also you can add a management portal where how you manage your reference data and master data, etc. Good. If you have any questions, please feel free to make it in your comment box, and let me know how this is helping you catch up with the data management concepts. And yeah, uh, wish you good luck. We'll see with a new topic in the next video. Thank you.